All right, good morning. Welcome back to PreCalc. So we're going to be talking about final exam review stuff, but this is how to do an exponential equation. So this is a very standard question. You should absolutely expect a problem like this. I would lose zero sleep if I put this problem on your final, and yeah, this is what I would expect everybody to be able to get, okay, or at least something like it. So here we have 5 raised to the 5x minus 2 equals 20, 1 minus 2x. Okay, so we'll go ahead and have a look at that. So we'll just write it down here. I don't have ways of saying that whether or not it's right or it's wrong. I just have to know. Okay, so let's see here. Where is my, there it is. Oh, beautiful. Second. Okay, so here we go. Draw. All right, so what we're going to have really, okay. So what we have is a 5 raised to the 5x minus 2 equals a 20 to the 1 minus 2x. Okay. So really, this is the whole problem that motivates why do we need logarithms in the first place, all right? It'd be nice if the bases were the same, that we could equate the exponents, but that is not the case. The fact that it's 20, okay, is there to mislead you because I made it a multiple of 5 on purpose. So thinking that you might divide by 5 first. That would be, you'd be very unhappy. Okay, that would not be a good way to go. Okay, because if I used 25, yeah, we could do something with that. If I used 125, we could do something with that. If I used 625, we could do something with that. But it has to be a 5 raised to a power so that we can equate the bases. But we can't do that because this is 5 times 4. That's not 5 times 5 or 5 times 5 times 5. It's not that. So what we have to do is we have to take the natural log. We have to take a logarithm on both sides. So I'm going to take natural log. Does it matter which logarithm we take? Not really. So we have 5 to the 5x minus 2. Take whichever log you feel comfortable with, okay? If you're going into calculus, natural logs are going to be the way you want to do everything, because in calculus, log base 10, which is the LOG button on your calculator, that has a correction factor attached to it. And you're in the middle of calculus, you have to remember, like, what was that correction factor? Like, I would have rather just used natural log and not dealt with anything. Okay, so what's going to happen is this guy here is going to come down in front. This is the rule of logarithms. This guy here is going to come down in front. Again, this is the rule of logarithms. So this is ln of a to the r is equal to r times the natural log of a. That's a rule of logarithms that you should know. Okay, so we have 5x minus 2 times the natural log of 5, and that is equal to 1 minus 2x times the natural log of 20. Okay, and I'm sure the natural log of 5 and the natural log of 20 are delightful numbers, but we don't really care what they are. Okay, so we're going to have 5x ln 5 minus 2 ln 5 is equal to ln 20 minus 2x ln 20. The whole point now is we're going to shuffle this, so we're going to get all of our x's off to one side. So we're going to add 2 natural log 20 to both sides. That's 2x ln 20. And I'm going to add 2 ln 5 to both sides, plus 2 ln 5 to both sides. So what we're going to have here is we're going to have 5x ln 5 plus 2x ln 20, and that is equal on the other side to, we have natural log 20, okay, plus 2 natural log 5. Notice here, the x is common to both of these terms, so we can factor that out. We could have x times the quantity, 5 natural log 5 plus 2 ln 20. okay, is equal to this stuff. ln 20 plus 2 ln 5. Is there a way to simplify that? Yes, there is. We'll get to that in just a moment. What we're going to do now is we're going to divide both sides here by 5 ln 5 plus 2 ln 20. Okay, we have 5 ln 5 plus 2 ln 20. Just divided both sides by this stuff. And our problem here, okay, is we're going to have x equals, okay, we have ln 20 plus 2 ln 5, all divided by, okay, I probably should have tilted my board in a better way here. Okay, sorry, I'm like writing an extreme slant. Okay, and then we have 5 ln 5 plus 2 ln 20. That's the answer that I would want. Okay, yeah, you could type that into a calculator and get a numerical approximation. 4 decimals is your standard, but that's actually the exact answer that I would want you to see with this. Okay, so just kind of review one back from the beginning of the semester. But you should absolutely expect a problem like this because this is like your standard, do you know what a logarithm is used for kind of a problem. Okay, so it would be criminal if I were to set you off to calculus without having you finish this kind of a problem. Okay, so we'll keep that and I will see you in the next video. Thank you.